is the bio theorem. We haven't posted in a while, so to anyone who sees this video, hey, thank you. Today we're classifying numbers. I learned this in Algebra 2, and I'm sharing this knowledge with y'all today. Alright, and we're going to do this with square dot, our best friend, so let's get started. So let's talk about sets. When we're classifying numbers, each number is grouped with other numbers based on a specific thing. These groups are called sets. And numbers can exist in more than one set. So this is our diagram. You might have seen something like this with classifying shapes or in middle school. We'll start off with the smallest circle. Our first set is natural numbers. These are going to be your positive whole numbers. You can write them as fractions as well, like 10 over 5, 2 over 1, etc. It is debated whether 0 counts as a natural number, but regardless, this is our set, and the set notation is right there. It is the letter N. That is the letter used to represent the set. The next set we got is integers. This is represented by a letter Z. So these include positive and negative numbers and 0 as well, whole numbers specifically. You can write them out as fractions and square roots, like the square root of 16 or negative 60 over 5. As long as your answer after simplifying is a positive or a negative integer or even 0, you're good to go. Now, the cool thing about this is that N is a part of set Z because, well, natural numbers are integers too. It's like all squares are rectangles, but not all rectangles are squares type of thing. Natural numbers are like our squares, and the Z set is like our rectangles. Not every number in the Z set belongs in the N set. That's why it only works one way, and you'll see this as we go forward. Now, we move into the next set, rational numbers. This set's notation is Q. This set includes the numbers of sets Z and N. You get rational numbers when you divide P over Q when Q is in 0. So, in other words, you divide two integers, they can be positive and or negative, but the bottom number can't be 0. But there is a catch. If you get an integer after dividing, you don't have to worry, but if you get a decimal after dividing, make sure that the decimal either completely stops or keeps repeating. That's why 0.8, the square root of 100, 200, 2/3 are all rational numbers. 0.8 completely stops, the square root of 100 is an integer, and 2/3 as a decimal is 0.6666, which means it's repeating. So all these numbers pass. Now, if you use the fraction 22 over 7, this would not work because if you divided both numbers, you'd get a decimal answer that never ends. These type of numbers would go into the irrational number set here, R minus Q, separate from our previous set's Venn diagram. Irrational numbers include pi, Euler's constant, square root to numbers that aren't integers, like the square root of 10, the square root of 3, the square root of 89, those won't give you integers, etc. All these result in decimals that never end, and that's why they're irrational. The cool thing is that the irrational and rational sets both come under the real number set. You can say pi is a real number, 0, negative 67, they're all real numbers. Real numbers are all the numbers you find on a number line. For some, you'll have to zoom in deep though to find them. And to expand your brain even more, real numbers fall under another set called complex numbers. These are numbers that exist on your average number line and those that don't exist on your average number line. Rather, an imaginary number line. Complex numbers include real numbers and imaginary numbers. Imaginary numbers are the square roots of negative numbers. I know it's confusing right now. Complex and imaginary numbers will be explained on our channel, so stay tuned for more about those. When you add a real number and an imaginary number, you get a complex number represented by a plus bi. A is a real number and bi is your imaginary number. Examples include I, which basically stands for the square root of negative 1, 0, 90, 0.5, pi, and negative 20 plus 6i. These are all random examples, by the way. Wow, so cool. Well, that's that from the bio theorem. Stay tuned for more. Also, guys, check the video description for practice problems, and see you guys.